only 4 of us. 6 of us. 4 of you, 2 of us, that makes 6 of us. All right.
Hocam ikinci vize olacak mı yoksa tek vize mi yapmaya karar verdiniz?
Yok, bir tane yaparız herhalde çünkü ertelenince çok sıkışacak.
Okay, I will come back to between essentiality because we did this before. Week number 3 we did it, but no, we didn't. Okay. Last week, the week before the examination, we mentioned about between essentiality. I want to go back to this one more time. It's like a step-by-step explanation, I would say. So here is how I'm doing this. Let me show you. This is again from the book that you download the chapter 3. You will see that, okay, this is on top over there. I have a network. And by just looking at it, I can see that it is breakable, that it is very fragile from the center. 5, 6, 7. We can break it apart. There are 2 groups, and it is, well, symmetrical. That's another thing. But, you know, left and right. But we can break it. So, we will talk about this between essentiality for the sake of, you know, how we can break up or how we can understand parts of networks. Because, well, for this it is simple, but for if we have so many thousands and or millions of nodes, we would like to understand, for example, about your Facebook or LinkedIn or whatever network. You cannot do it by yourself manually. You have to have the computer an algorithm to do that for you. For example, it can organize in such a way that your family is a map that is determined. Okay, this is my family. These nodes are my my school friends and stuff like that. So it is possible that an algorithm like that would understand. Well, of course, cannot understand which is your family and which is your friends, but can distinguish them. There's this bunch of people, and there's this bunch of people. They don't know each other very much, maybe a few links. So how we can do this? In order to prepare for that, we need to come back to the between essentiality. And this is an example. So what we do with the between essentiality is, first of all, we look at all the possible pairs of nodes, first of all. Like, I did something like this over here. It's, you can do it. It was not so difficult. I can do it, you know, I can show it how to do it. What I do is that I'm listing like 1, 2, 3, 4, 5, 6, and up to 11 on a row on this one. First, have ones over here. Put all this other nodes there, and then put 2s and copy and paste and copy and paste. So what I end up with is all the possible pairs that you can have with this node, in this network. 2 nodes is a pair, right? And I'm getting all the possible different pairs. List them out. And what I did is, you know, just to be able to show to you, I'm going to use this part here. This is my, of course, this is my network, and I'm going to construct something here that to be able to tell you what is, how I calculate the between essentiality. So I take the first one, 1 and 2, that are nodes 1 and 2, and I look at the shortest path between them. The shortest path between them is the edge 1, 2. That's obvious. So what I do is that I draw a line here, 1, 2, okay? So, you know, it's easy when you have any program like this, you can control the thickness of this edge, of this line. So I will use this thickness as well, I just wanted to mention it to you. So I look at the second one in this, 1 and 3. So what is the shortest path between them? Of course, only one step over here. So I draw this one. Okay? Then the next one, it is 1 and 4. So this is a little bit tricky, of course, because you have two options. They are equally distant. They are all 2 steps. I can go either from 1 to 2, then to 4, or to 3 and then 4. So I list them all. I say it is 1, 2, 4, or 1, 2, 3, 1, 3, 4. So what I do is that I map them all the alternatives. I say, okay, from 1 to 2, so I change the thickness from 1 to 2. So I'm using the thickness here as a memory. You know, like I'm recording it. And these are thickness 1. So let's go on. From 1 to 5, this time I want to go to 5. Of course, I'm not going to be going from 1 to 2, then to 4, and to 5. No, what I do is that I go either from 2 to 5 or from 3 to 5. So I change this one. This is getting thicker now. It gets now 3 pixels thick. And these are all 2 pixels thick. And it goes on. This time it is 6. It is 1, 2, 5, 6, or 1, 3, 5, 6. So as you see, these guys are getting 4. These are 2. And this is 2 again, because in both cases this has been used. So it goes on like that. I mean, when it is 7, as you see, it's getting thicker and thicker. So I can do this. Oops, yeah, I will go back to cytoscape at this point. So I can do this for the whole thing. So what I do is that what I'm doing here, I have all the possible pairs and finding the shortest path between those 2 nodes in these pairs. And what I do is that I count how many times that we are passing through each edge. How many times we pass through each edge. And if there are more than one possibility for the shortest paths, I take them all. I count them all as well. So this is how I do it. And of course this is not yet between the centrality. What I end up is some numbers like integer numbers. Some of them will be like 11, some of them will stay like 1 as the edge. Then I have to find the between essentiality. What I usually, of course, what we would like to do as engineers, we don't like those kind of things like numbers, just integer numbers without any limit. We don't know where it is going to stop. So what we would like to do is usually, we would like to normalize them, right? We would like to normalize them like between 0 and 1. So we should normalize this as well, like a percentage. Okay? What would you think that how can we normalize it? How can we normalize this? You know, I have this number now, maybe 6, and I want to normalize it. That it should be a number between 0 and 1. And also, I have to keep in mind that, for example, if I have 2 nodes, all right, and I want to calculate the between essentiality between these 2 nodes, it's going to be 1. I want this to be 1. All right? Does it make sense? So I want for each node here, for each edge, I want a number between 0 and 1, and it has to make sense. Now I'll calculate it, how many times that I'm passing through these, accounted for all the possibilities. And now I want to know what would be the normalized value for that. So I have to divide it to a value, right? I have to divide it to a value. Do you have any idea that what shall we divide it to? Okay. Let's start from something simple then. As I said, I have two nodes. All right, I have an edge. And, well, my gut feeling, or, well, this is not maybe the gut feeling, I don't know. Well, this has to be 1, right? You know, I want a number between 0 and 1. This is going to be my between essentiality. I want my between essentiality to be normalized. I don't want, like, 0 and 267 in one case, and 0 and 2,100,000 and something in the other case. I want, for all cases, a normalized number, like between 0 and 1, right? So for this case, it's obvious that, you know, I know that it has to be 1 because there's only one of them. Okay? How about this case? What is your feeling about this case? What should be the values for these edges should be? Like, you know, if we, because let's call them A, B, and C. I can have A, B, B, C, and AC pairs, right? So I just wanna, you know, very simple. Very, very simple. This I can understand. Let's call this again A and B. So I have only one pair possible. And I want to find the shortest path in between two of them. And I say, okay, that is 1. All right? I don't need to normalize that. I mean, well, this is already 1. So all of the shortest paths, I look at all of the shortest paths. That's all of them, and that's 1. In this case, there are 3 of them. And linked like this, I don't have a link between A and C. Doesn't matter. So what I do, I have all the nodes, and I write all the pairs. Are these all the pairs? Are these all the pairs that's possible? These are all the pairs that are possible. So how can I go from A to B? That's from A to B, right? So I use it once. Let me write it like that. I use this one, this path once. How can I go from B to C? B to C. So I use it once again. How can I use A to C? How can I go from A to C? I can go through B, right? So, right? So then what happens is these become 2 because you see that I'm counting the numbers here. How many times that I'm passing through each edge, okay? So in that case, what would you think that if I want to normalize this, what would be the numbers? That's an interesting question. No answer is, well, what you are going to say is very interesting for me. Are you, or at least, are you going to say something? That's very interesting as well.
This is 1 over 2.
No, I say, look, well, these numbers are 2 and 2, and it gives me some information, isn't it? But it gives me some information that these 2 are equal in terms of importance, I would say, or importance, that means that how many times that I have to pass for all the trips, all the shortest trips in my world, in my universe. This is my universe. All the trips in this universe are this. So there are this many trips possible. And in this many trips, I travel this many times from each edge. So what I say is that they are equally important. Right? But what happens is, you know, I repeat again, I don't want if I was going to have something like this, I will be having, you know, the maximum number for any edge when I count will be, for example, I don't know, I have to look at it, but maybe 22. Okay, for this case it is 22. So I will be having one edge being 22. There will be another edge that has 3. There will be maybe 4 5s. I don't know that. But what is really not nice is that the numbers are changing all the time. Like for this case, it is, you know, it's something from changing from 0 to 22. And for this case, it is only 2 and 2, right? So I want to get rid of this. So what I want to do is to make them all between a number between 0 and 1. So I want to convert these 2's to a number which will be between 0 and 1. So that, sorry?
0.5.
Oh yeah, it's a good idea. You say 0.5 for each of them, so that I know that they are equal.
Say 1.
Sorry?
1. Instead of 0.5. Because this is our network, and we really don't compare this network to other networks, so we can just call them.
Yeah, you say that obviously. I mean, if you're talking about 0 and 1, then it can be anything like 0. Or it can be even 0. You say it can be, I don't know, 0.1 and 0.1. No, but I have to. Okay, now then I have to move on. Shall I do this? I mean, yeah, I think I shall do this. Let's have, okay, a different one. Easy again. What's going to happen now? What do you think will happen? Can we just intuitively, like, I believe that these two will be equal, right?
3, 3, 4.
And this is going to be a higher number, right? Like, what is that?
3,
3, 4, 3?
4. Yes. 3, 4.
This is, yeah, I don't know. Yeah, probably. I don't care. This might be true. Okay?
4 çarpı 1 bölüm o zaman yazıyoruz.
Oh, he has a suggestion. What you say? Can you repeat again?
C
No, give me a general idea. You know, how did you do that? Where did you came up with 10? He says divided by 10.
because yani sayıların 3 4 3 ya. Onların toplamı yani toplam zaten gidebileceği yol burası yani 3.
Okay, so he says, you know, why don't we take the total number and divide it to them? So the total number is 6, right? 3 plus 4 plus 3, it is 10. So he says, let's divide them all 10. So I have all the possible trips, number of them, and so it's normalized between 0 and 1.
I would rather divide it by 6 because there are 6 possible links.
Okay. You say, let's divide it by 6. I have to think about
A,
it.
B, B, C, C, D, D, B, A, C, and A, D.
I know, no, I got it. Yeah, there are all the possible links are 6.
What? Dolaptan yani topladığımızda 1 olmuyor. O zaman birden fazla oluyor.
That's great.
No, it's, yeah.
And why we should we can look at the percentage contribution of each link. I think that.
Percentage contribution.
For example, yani yüzdelik şeylere bakmamız gerekmiyor mu?
What is,
Yani ona burada olmayabilir ama hani her birinin hani yüzdelik olarak ne kadar katkıda bulunduğunu bilirsek hani direkt bunu
are you talking about weights?
yani arkadaşımızın dediği gibi hani mesela bu 10 olabilirdi ama hani 11 olabilirdi o toplamları. Her seferinde hani her ihtimali, toplam ihtimali bakıp bunun yüzdeliğini alırsak eğer oradaki hani şey bulmuş olmaz mıyız? İkisi arasındaki hani possibility'sini.
I didn't understand. Does somebody understand? I really didn't understand.
And there are two suggestions. Why don't we wrap it up?
Yeah, okay. Yeah,
There are two
suggestions.
suggestions. One suggestion is basically count the number of times that the links use and
Yeah.
sum them up and divide by the number to normalize it or get the percentages. Atakan says not count those, but count the in how many number of ways we can, rather than how many number of ways, how many number of possibilities. But Atakan's way of thinking is not going to cure your idea because, for instance, the possibility, okay, there are 4 nodes and 2 links. A link involves only 2. So Atakan calculates 6 because it is the combination of 4 to 2. You know, it's a direct combination of 6 numbers. However, each 6 numbers involve more than 1 link. So for instance, if you're going to go from A to D, AD involves 3 different numbers. On the other hand, AC involves 2 different numbers. And you would like to distinguish this. So that possibilities must be weighted by also the number of links that is going to be used in those possibilities. So I'm afraid Atakan's suggestion is not suitable for your case. Is that right, Atakan?
Yeah.
Yeah, because AD involves AB, BC, and CD. On the other hand, AC involves AB and BC. But now, even though AC and AD are 2 strict possibilities, but one involves 3 links, the other one only involves 2 links, and your suggestion doesn't take into those differences, into account. So it's basically what Chris is suggesting, I understand, is creating the histogram. And then is trying to get the probability out of the histogram, basically summing the number of possibilities and dividing by the sum. So then it is exactly the probability. What is the probability of using 2-5 link in the network if you were to reach any arbitrary 2 points in the network? So he's creating the probability, I guess.
Well, yeah, exactly. But I tried to explain it to a different. But I never thought about that. There could be another alternative, and it's very difficult to talk about why it doesn't work. But it is interesting. Anyway, so what I'm going to do. It's not interesting.
It is, but I think we have the answer. So
Yeah, no, we have the answer, but I didn't want to go from this is for me more simpler than telling you about all distribution, histogram, and possibilities. That's easier to talk about it, in my opinion.
Yeah, exactly.
Yeah,
But
but
you see-
then it raises. I never thought about that Atakan was
Exactly.
going to be coming here today and telling me this. I didn't do that.
Now we need to distinguish though why
Yeah.
the suggestion is maybe okay in one case, yes, but not in that case. Because you're exactly after counting the
Yeah.
number of links. And the other thing is, obviously, I think we spent around 30 minutes or so to discussing this, and I
Yeah.
think this is most appreciated, and it should be done. Why? Because even though we're taking courses in probability and statistics once, and we never use those things throughout the life of civil engineering, and then those concepts are not really digested or internalized properly. Even though, if it is used in some classes, it's not exactly taken or put forward as you do, and then it can become useless. So I think we should appreciate the way that you try to put our mind those words, even though it should take 30 minutes, it really doesn't matter. Now what we understand, another way of thinking those things are in a general mathematical language called histogram and probabilities. And I agree with you that we shouldn't discuss these issues starting with histogram and probabilities.
Anyway,
But at the end, we should go there because this is the universal language.
Yeah.
And it should have taken, it really doesn't matter, it would have taken an hour. It will be also more useful, I guess.
Okay.
But for instance, rather, I thought you were going to go, not a line, but going to create a triangle and going to do this in one more time. So,
No. In that case, it's going to be all equal. Anyway, so what I'm going to do now is go back to Saito scale. Okay. So I already did it a little bit, but I didn't completed it just to be able to show you, to do it with you rather, actually. So just to remind you that how we are doing this. So, you know, it's gonna be, I did this 7. So what I was doing, you remember, I double click here, write the name, so I have an 8 here. And up here I have a 9, I guess. Is it correct? There was a 10 here. And there's an 11 here. So what I want to do now is to show you how I can get, again, between the centralities from here. All right? So what I do, again, now to draw the edges, I drop this edge here and click on 8. I drop this on 8, connect it to 9. 8 connected to 10.
I accidentally export something. If you press Control and click.
Oh, you
on-
find a shortcut? You do what? Control?
Pressing Control, you click one of them and the
Oh.
other. It makes it.
It doesn't work on my computer. Or maybe it's a command. No.
Maybe because I use Windows.
Yeah. Probably that's the reason. Is it now okay? No. There are going to be two more links. Okay, now it's finished. All right. So to calculate these between the centralities, we go to plugins, network analysis, analyze network. We say this is undirected, and it's finished. Okay, we have all those usual things. Oh, and this is the shortest path length distribution. Now, what the computer, okay, let me do this first. So, all right, it's calculated. We are not able to see it yet, but now I'm going to show it to you. So how I'm going to show it to you is take this a little bit up. I will select all of them. I will go to Edge Attribute Browser. And I select Edge Betweenness. Oops. Here it is. I have these edge betweenness numbers. So what I can do, I can copy them and put them into an Excel file. And I can, again, of course, create this histogram. I can normalize them. Or, if you go to, so that means that for each of them, you know, if I click, I know what it is. So, just to know, if I click on this, this is 50, okay? So just to get a feeling about what's going on here. If I click on this, this is 10. 10, okay. What is this going to be? Is this kind of important? I think it's important. No, it's not important. 14, so maybe this is more important. Yes, this is more important, 21. Because 21 cases out of, I don't know how many total, it's, you know, I can compare. This is 50, this is, I guess, the maximum number. Maybe one of these are minimum, like